This is the second part of section 3 for chapter 1. Last video we talked about any 2 points being collinear. That's a postulate. That's a fact. Here's our second postulate for chapter 1. It says if 2 distinct lines intersect, then their intersection is a point. The word you might not understand there is the word distinct. That just means different. So we have 2 different lines there. We have line M. Notice how M is not a point on the line. M is a lowercase letter. It's the name of the entire line. We also have line L. L again is lowercase. It's the name of the whole entire line. Those 2 lines cross each other. Anytime that happens, they cross at a point. Just one point, one location. So it's really easy to see where they cross here. Line L and line M intersect at point T. Let's look at an example. Name the intersection of line DE and line EF. Notice how they're using the shorthand notation there. 2 capital letters, order doesn't matter. Arrowheads over top. Again, look at line DE. That's an acceptable name for that line, but you could have also used point G in there somewhere because G also lives on that line. Do these 2 lines cross? They definitely do. Where do they cross? Well, the postulate says they're going to cross at one point. Which one point is on both lines? It's point E. You can see that by looking at the diagram. Also, you can tell just by looking at the names of the lines. If you didn't have a diagram, you would still know that they cross at point E because they both have E in the name. Okay, so that's our second postulate. Anytime 2 lines cross, they're going to cross one time at one point. The next postulate is actually our fourth postulate. Skip the third one because it's a little bit tricky. We'll probably get to that one in the next video. This one talks about planes intersecting. Remember, planes are flat surfaces. They go on forever in all directions. They have no thickness. If 2 planes intersect, then their intersection is a line. So below there's a diagram that shows that. Some of you might be able to visualize that better than others. If you can see those 2 planes, one's vertical, one's horizontal, if you can see that they touch each other, hopefully you recognize that they don't touch each other one place, like 2 lines crossing. They touch each other in infinitely many places, all along that line, that black line there. We would call it line AP. If you have a hard time seeing that, I would give you this example. Think about your floor in the room that you're in, and think about any one of the walls. Does the floor touch the wall? Definitely. How many locations do they touch? Do they touch once? Do they touch twice? Do they touch 3 times? Okay, they touch infinitely many places. Any 2 places you find that they touch, you could always find another place in between there that they touch also. Okay, so if you're looking at that diagram and thinking of the room that you're in, point A and point P would be like the corners of the room that you're in. Now remember, there's infinitely many points in between those corners where they touch also. And since planes go on forever, pretend that your floor goes on forever and your wall goes on forever. They're going to touch in all those points as well. Okay, so that's a good way to remember this postulate. When 2 planes cross, they cross at a line, infinitely many places. Here's an example where you would use that postulate. So again, this figure is going to look a whole lot like the room that you're in. There's a floor, a ceiling, and there's 4 walls. We'll call it front wall, back wall, left wall, right wall. The figure shows the intersection of 6 planes. Name the intersection of plane CDG. Hopefully you know where that is. And plane BCD. Hopefully you can find that as well. Remember, to name a plane, you only need 3 letters. There's only one plane that has the 3 points C, D, and G. Is it the floor, the ceiling, the front wall, back wall, left wall, or right wall? Okay, hopefully you recognize that that's the ceiling. On your notes, you should probably write that in there. Write ceiling underneath those 3 letters, CDG. Find plane BCD. That's the left wall. Write that in there on your notes. Does the ceiling touch the left wall? Absolutely. It doesn't touch it once, it doesn't touch it twice, it doesn't touch it 3 times. It touches it infinitely many times in the shape of a line. Which line touches both planes? If you're looking at the diagram, hopefully you recognize that it's line CD or line DC. That's acceptable as well. If you're not looking at the diagram, you can still get the answer. Notice how the letters C and D are in both planes. That's a dead giveaway. If you have 2 letters in common in the names of your planes, that's where they intersect, that line.